Morning.
All right. Just going to give about another minute or two here, Austin, and let everybody join up.
Sounds good.
Morning, Paige. Morning, Morgan. We'll start on page 266 this morning. All right. Okay, so what I'm going to do this morning is go through a couple of these examples. These are along the same lines as a question in the 6.3, but they are word problems that tend to give. There's a bit of difficulty, and I'm going to be honest with you. I'm going to have a hard time explaining the first one, and then I'll get it going, and I'll get into a rhythm, and I'll do a better job. But right away, I usually have a difficulty. So let's have a look at it. Now, these questions, these word problems, we set up charts for them. It's the easiest way to do this question. And then from there, when we can, the solving part is actually the easy part. It's setting up this question that makes it a little more difficult. Okay, so it says Andrea and Ferry are sharing a bag of popcorn at the movies. By himself, Ferry can eat the whole bag of popcorn in 20 minutes. Andrea takes 25 minutes to eat the whole bag. If they both eat popcorn at their usual rates, how quickly will they eat the bag of popcorn? Okay, so here's what I have. I have Andrea. I have Ferry. And I have together. So the total time it takes for Andrea to eat a bag of popcorn is 25 minutes. The total time it takes Ferry to eat popcorn is 20 minutes. And then together, it's going to take them X minutes. So that's our intended goal. We want to see how long it's going to take for them to eat a bag of popcorn together. All right. Now, here's where the question gets sort of confusing. So I'll do my best to explain it, and then we'll talk about why we do it in a second. All right. So the next thing that we want to do is we want to see what portion of the popcorn is she going to eat in 1 minute. So in 1 minute, how much popcorn is she going to eat in 1 minute? Well, she's going to eat 1/25 of the amount of popcorn in 1 minute. All right, if it takes you 25 minutes to eat popcorn, a bag of popcorn, then it's going to take 1/25 of a minute to eat popcorn. Then it's going to take 1/20 of a minute for him to eat popcorn. And then together, the amount of popcorn they're going to eat in 1 minute is 1/x. Okay, so far. Make myself some room here. So then what we want to do then is we want to see what is the fraction of popcorn eaten in X minutes then. So this is the fraction in X minutes. So now think about it. If I said to you, okay, let's take 12 minutes. Just a random number, 12 minutes. Well, how much popcorn is Andrea going to eat in 12 minutes? Well, 12/25 of her bag. How much is Ferry going to eat? 12/20. What if it's 10 minutes? Well, he's going to eat 10/25 or 10/20. So it doesn't matter what I put in there. It's a portion of 25 and a portion of 20. So I'm going to go x over 25 here and x over 20 right here. So that is the fraction of popcorn eaten in x minutes. And then down here, I want to figure out, well, I need to eat one whole bag of popcorn. So the amount of time to eat one whole bag of popcorn would be x by 1 over x, which is equal to 1 bag. So the amount that x eats times the amount of x, 1 over x, the portion out of the bag eats, it equals 1. I really don't need this right here. That's just to show you how to get to 1, but I can actually erase it, and I need 1 bag of popcorn. So how much each person eats then is she's going to eat x/25 of that bag. He's going to eat x/20 of that bag for a total of 1 bag. So you would add up the amount of popcorn that she's going to eat, and you add the amount of popcorn that he's going to eat. So she's going to eat x/25 of it. He's going to eat x/20 of it. And you're going to eat 1 full bag of popcorn. So the most important part is this setup. And you'll see there's, I think, 4 or 5 questions in this section. And each one you're going to want to set a chart up for it. Now the thing is, it's almost like you just have to memorize this as to how it works. Okay? The understanding will come as we start solving, but for right now, if you can just memorize as to, all right, where it comes down to is right here. The fraction of the amount of popcorn he's going to eat is x/25, and the fraction we need here is x/20 for 1 whole bag of popcorn. Okay? So this is your kind of your money line that we're going to need in order to solve the question. So at this point then, we multiply by the common denominator. So we'll just multiply by 100. So that's going to give me 4x. So if I go 100 here, that leaves me a 4. 100 here leaves me a 5. So I would have that. 4x plus 5x is equal to 100. We're going to times this by 100. So I have 9x equals 100. And then I would divide by 9. So 100 divided by 9. And then the answer, it says here, should lie somewhere between half of Andrea's time and half of Ferry's time. Is this the case? Well, what's 100 divided by 9? 10 point what? No, 11. Should have known that. 11.111. So that's the number of minutes. Okay. All right. So we're going to look at this example 4. And then I'm going to answer some questions from how you made out on the weekend and all that. And then basically what I want to see you do is work through 6-4, those problems today. So I'll assign those 4 problems today. And then tomorrow we'll start looking at maybe possibly doing a review for it. Now, again, I'm not I'm going to continue to do the assignments, and testing will be done at the end of the units at the end of the week. I just basically want to wrap every Friday up with an assignment on what we did for each week. Rather than testing on units themselves, we're going to just wrap it up each week so I can keep a gauge as to how we're doing and who's keeping involved here. All right, so page 267, a group of friends go on a 3-hour bike ride. They ride 15 kilometers with the wind at their backs and then 15 kilometers straight into the wind. The wind adds or subtracts 3 kilometers from their speed. What is the average speed of the group? All right, so we've got with the wind, without the wind, and then we have our total. Now our objective is to find the time. So you'll remember that in order to get the time of travel, we have to take the distance divided by the velocity. So the total amount of distance that you're traveling, and you divide it by your velocity. Okay? So to calculate distance then, it says that they go 3-hour bike ride. They ride 15 kilometers with the wind at their backs and 15 kilometers straight into the wind. So our distance doesn't change. So we have 15, 15. So that means a 30. We have total of 30. Our speed, I use velocity here, but I can use speed. And I use displacement, so I'll use distance because we're not talking about direction. So our speed at which we travel at. Traveling with the wind adds 3 kilometers an hour to the speed that he's traveling at. Traveling into the wind, we subtract 3 kilometers from it. Okay? And we don't really need anything here. We don't really need anything here for our speed. Now our time it takes for this to happen is found by taking distance over speed. So 15 over x plus 3, 15 over x subtract 3, and the total distance or total time, okay, is going to be a group of friends go on a 3-hour bike ride together. So our total time is 3 hours. So what does x represent in this question? X represents the speed that they're actually riding their bikes at. Okay? So now I go 15 over x plus 3, add 15 over x minus 3 equals 3. All right, so I want to get rid of my denominators. So I'm going to times each one by x minus 3, x plus 3. Cancel where I can, so I have 15 times x minus 3 plus 15 times x add 3 equals 3 times, I keep going on the wrong side here, sorry, 3 times x squared minus 9. Get rid of all my brackets. Get everything equal to 0. All right, minus 45 and plus 45, they cancel. So I have 3x squared minus 30x minus 27. Greatest common factor. Because I have an equal sign, I can divide it out completely. So that gives me 0 is equal to x squared minus 10x minus 9. Something doesn't feel right about this. No, it's right. It's not factorable. So all right, so the first thing I check is it factorable? I've noticed that it's not factorable, so now I have a choice. Graph it. Okay, you could use completing the square if you want. I might use it just for fun right now. So I have complete the square. And then your quadratic formula. So again, we're using everything from previous minus 30x plus 15 squared minus 27 minus 15 squared. 0 equals x minus 15 all squared. Subtract. $252. So I put the 252 over here. X minus 15 squared. Okay. Square root it. Plus minus. Add 15. Now, because I'm doing an actual problem, okay, because I'm actually solving here, I would actually use my calculator to solve this question. So I would go 15 plus the square root of 252. So x is equal to 30.875. And then I do 15 subtract square root 252. And I'd end up with a minus here, which I clearly can't have. So how fast were they traveling on their bikes? Fairly quickly, I would say. 30.875 kilometers per hour. So again, this is a type of question that is a lot of work. A lot of work. It's not real labor-intensive work, but there is a lot of work, which means there are areas in which I can make errors. So we have to be a little more careful with that. All right. So just to look at the amount of work, there's your 2 pages full of work. All right. So have a look on page 271. 272. There's four problems there. If you happen to go through those 4 problems, 4, 5, 6, and 7 today, that's a good day for you. All right, they're not tough. You have to do them the same way, but if you can get through those 4 problems, you're doing all right today. All right. Okay, that's all basically I wanted to cover today. I think I can't really tell because I haven't. Let me just have a seat. I'm just gonna check to see who's online here with us. Okay, so I've got. I'm still missing a couple of assignments. Okay, there's quite a few of you that got assignments in, so that's good. If you can get them in today, that would be ideal. If they can't come in till tomorrow, that's fine. Okay, that happens. So I won't cover any information. Okay. On Wednesday, I'll go through the assignment with you to give you the answers for the assignment. And then we'll see where we get to at that point, whether we need another day of review or we can move on. But I'm just going to quick look here. I think there's 9 sections in this guy. So we're in decent enough shape. We're not quite into May yet, so we'll try and get this done. The majority of this will be done by no later than the middle of June, maybe earlier, I guess. We'll see how it goes. Okay, so now what I want to do is I want to open it up to questions, whether they're from 6-4, if you started that on Friday, or if you had questions from 6-3. So if you want to open that up, have a look at your book this morning. Although I think we did a good job of 6-3. I think 6-4 is what you should have been working on more than anything. So go ahead. I'll open it up. If you want to turn your mic on to ask a question, feel free. Okay. Then maybe what I would do is I would have a look at question 4 right now on page 271. And while we're still on here, I'll just wait in case we need to go through it. But have a look at question 4 and see if you can set it up yourself. Use your example number 3 to help base your chart for number 4. So I'll leave that open right now. We'll stay on the line for a little bit longer. And if anybody has anything they want to ask, feel free to do so. Okay. So go ahead, work on number 4 and 5. And even if you can just set them up, you don't have to solve them yet, but just set them up. Set your charts up and then go back and solve them after.
I kind of have a question about stating the non-permissible value.
Okay. Go ahead.
Pardon?
Whereabouts would you like to look at it?
I don't think it's really any specific question.
Okay.
That it's just like, say if something was like a cubed.
Yeah.
Or a squared.
Okay.
And I'm trying to like
Yeah. All right, let me show it to you like this. Okay? This is the easiest way. So first thing that we are trying to avoid. First thing we're trying to avoid is that we do not want a 0 on our denominator, right? That's where the non-permissibles come from. So when I look at them and I break them down, depending on whatever the denominator is, if there's a variable on the bottom, I don't want that variable and whatever else is on the bottom with it to equal 0. So in this case, I'd say, okay, x can equal 0. X minus 3. X minus 3 can't equal 0, therefore x cannot equal 3. Because if I go 3 subtract 3, I would get 0. If I have something like this, a squared b, let's say, that means that a can't be 0 and b can't be 0 either. So I write that as twice. I say, okay, a can't be 0 and b can't be 0. Because if a is 0, 0 squared is still 0. 0 times b is 0. Yeah. B is 0, so 0 times a squared, still 0. So I can't have a 0, therefore a or b can't equal 0 in that case. All right?
Okay.
And then if I had something like this, x minus 2, x minus 1. All right? What are the two values that x can't be because I'm going to end up with a 0 on the bottom? Well, x can't equal 2. X also can't equal 1. Because if I put a 2 in here, 2 subtract 2 is 0. 0 times 1 is 0. 1 subtract 1 is 0. 0 times x minus 2, still 0. All right?
Thank you.
Does that make, okay? Let's leave that up. Okay, and for everybody else, how are we making out with 4? Everybody's trying it at least, I hope.
Mr. Newton,
Yes, Austin?
I did number 4, and I think I set the table up right, but I don't know how to get my final answer. I've got x over 10 plus x over 15 equals 1.
Yeah.
Is that how you do that?
Yes. Because you're shoveling one driveway, right? So the portion that Rico is going to do will be x over 10. And the portion that Fanny is going to do is x over 15. And combined, that'll give you one driveway.
So then you have to get rid of the denominator.
That's right.
So let's say I divide it or times them both by 150.
Yep.
Then I have 15x and 10x.
Yep.
And that's 25x.
Yep.
So then I have 25x equals 1. But
no, equals 150. You got to multiply the 1 by 150 as well.
Oh, right. Okay. Thank you.
You're welcome. There's one trick with 6. 6 is still done the same way as the other example, that example 4. The only difference is that you have to add that 30-minute break in there. So it's a half an hour. Okay, so I'll help you out with this. So we've got distance from...
I just don't know like what it's comparing. Is it comparing the time?
Well, does it give you a total amount of time?
Not really.
No, are you sure?
No.
All right. You know, you go from you're going from Calgary to Red Deer and back, and it takes you 3 hours and 15 minutes, right?
Yeah.
So you know the time, the total time. So when it comes to that chart, then you got 3.25 hours as your total, right? So to do it, I'm going to go Calgary to Red Deer to Calgary, right? And then that's my total trip right there. Okay, so just solely based on that other example. So we have distance. What's my distance covered? So far, so good, right, Amy? We've got 140 there and 140 back, right?
Yeah.
Okay. So then the speed, what happens with the speed here? We don't know how fast they're going. And then it says, drive to Red Deer, half-hour break, and then return to Calgary. Traffic is busier on the return trip, so the average speed is 10 kilometers an hour slower on the return trip or the outbound trip. So if my speed to get there is X, I'm going to go X minus 10 on the way back, right? I'm going to go slower on the way back.
Yeah. Okay. Yeah, I just didn't know like what to put in the chart. Like I didn't know if it was supposed to be the time in there or the distance or the speed. Like I just didn't know how to like set it up.
Okay, so just following along with that other example, this is what I would do. Okay. So now the time again would be 140 divided by X, 140 divided by X, subtract 10, right? And then the total trip is 3.25. But the key to this is I also have to figure out that extra half an hour as well. All right, I have to take that away from the travel time. So what I have is the total time this trip takes is 140 over X, 140 over X, subtract 10, not 20. And I'm going to change this to 2.75 hours because I need to subtract the half hour of downtime, that half hour stay over. Okay?
Okay, perfect. Thank you.
Okay, no problem. Amron, I just read your note. You can hand that in tomorrow. I just said that if you were working on it today, that'd be ideal. But
Yeah, I just heard it like before.
Okay, so you sent this earlier this morning?
Yeah, I sent it at and I sent it on the freaking
Edmodo?
the grade 12 physics. I didn't even know I was still on there. That's why I was late to this thing. So I thought, 11. Okay, that's.
Yeah. Okay. All right. So you're good then.
Yeah.
Okay. Morgan, are you still on here somewhere?
Yeah, I'm here.
How are you changing your assignments to PDFs? How are you scanning them?
It's on my iPad. I have this app. It's for our printer, but I'm pretty sure anybody can get it. And then it's just called a camera scan. And
Okay.
then when you go to mail it, you just choose it as a PDF.
Okay.
Yeah.
For anybody else out there, it works way better if you can scan that because then I can print it all at once. I'm not printing individual copies. I'm okay with it if I have to print off 5 pictures, but that works great if you can do that for the record, for everybody still working on assignments.
And my mom used the app called Tiny Scanner or whatever too to scan them as a PDF and then mail them in.
Tiny Scanner? Amron, did I hear that right? Tiny.
Oh, sorry. Yeah, I think so. That's what she uses.
Okay. And it's something on the phone again?
Yes. It's a PDF. That's what I'm handing my English in.
Okay. That works slick. I got to talk to my grade 10s about this because they keep sending pictures in. I got to print 5 pictures at a time. Okay. Any other questions this morning? Should be okay, I think. Anyways. Oh, it's so hard to see. All right, is everybody okay? One last call, and then I'll maybe close this up.
I'm good.
Thank you.
Just quickly on the board behind you, you have 140 over x plus 140 over x minus 10.
Yes.
Times the minus 10 by the first term and the last one, right? To get.
You don't times no. You have to times everything by x minus 10. Like that. That cancels. That cancels. So you're gonna get 140 times x minus 10 plus 140x is equal to 2.75 times x squared minus 10x.
Okay, thank you.
Yeah, no problem. You'll end up probably dividing everything by 2.75, I think, at some point, I believe. Okay, I'm going to leave it as is. So tomorrow we will look at the review in the book. I'll answer questions from this. We'll look at the review in the book tomorrow. It's not a real long review. There's only 7 questions. And then Wednesday I'll go through the assignment with everybody and tidy up that chapter, and then probably by Thursday we'll start in on chapter 7. Okay? All right, everybody.